Hello, welcome back. I'm Victor, and in the last video we found about and we solved quadratic solutions, equations, sorry, and found the roots of a quadratic. And now what we're actually going to do is we're going to learn how to sketch the full parabola, the vertex of the parabola itself, and where to find these actual points, starting from the single most important point from any quadratic graph. And so what I want to do is I'm going to be plotting those points right away. So let's find that. I'm going to plot y equals x squared. Now I'm going to plot that. When I want to plot that, I'm going to have to plot the points first. And so when I need to plot the points first, I usually make them so that they connect with each other and they're connected well and something like that. So I'll plot this point, 1 point here, 1 point here, 1 point here. I'll explain the points later, of course. But it's essentially how if even x is -1 or x is minus or +1 or 2, something like that, their values will be equal to on the y-axis right here. So I'm gonna map them all out. So 1, 2, 2 here will be 4. So this will be the value for it to actually be easy. I just usually map them very symmetrically. So I just find I'm like, oh, so that's the parabola. So and it's gonna be something like this, but that's for later. I'm actually mapping these out because it doesn't have enough space, but yeah, but this should be like enough for now, suffice for now. This is 9, by the way. This value is 9. It only allows for 8 here for some reason. Why is it looking so glitchy all of a sudden? Anyways, let's just draw them out. Let's map these points out, connect all these points together. Please not right now. Again, that was a little bit ugly. Try that again. Okay, that was not the best parabola ever, but again, this is just for demonstration purposes. Let's start with the first simplest quadratic. I'm going to draw it next to here. This will be y equals x squared. Now when x is 0, then y will be 0, of course. When x is 1 or -1, doesn't really matter, then y will be 1. When the same thing is going to happen when x is 2, then it's going to be around 4 here, as you can see at these points. And so this U-shaped curve, this is called a parabola. And every quadratic we ever graph is just a transformed version of this shape. Okay? And so I also have another important point here that I would like to draw. And this point right here, this red point. And this is called the bottom of this U, the center part of here. This is called a vertex. So for y equals x squared, the vertex is at the origin, 0. This is 0 right here. So if you know the vertex, you know where the parabola sits, and the rest of the shape follows. Because, as you can see, on the left-hand side, they go like this, and on the right-hand side, it will go very symmetrically. It is symmetric. So, let's draw a very vertical dashed line here. It's going to be in red. The y-axis does it for us, but I'm going to just draw it for you right here. The axis of the symmetry is at x equals 0, so the parabola is perfectly symmetric around this vertical line right here. This is the axis of the symmetry. Every point on the left has a mirror point on the right. So I just explained to you a little bit about symmetry. Okay, so we have learned how to plot and draw our most basic form here. Now I'm going to go into the more complicated forms where we will have a little bit of a vertical shift or a horizontal shift? Now I need to plot first. Y, excuse me, that should be in yellow, but that's fine, equals x squared plus 3, of course. Now what happens when we plus 3? Y equals x squared plus 3. The entire parabola shifts up by 3 units. So it goes from 0 to 3. Because if we put like something like 0 here plus 3, then y will equal to 0 to number 3. If we put something like 1 plus 3, then it will be around 4. If we put something like 2 plus 3, 2 squared plus 3, of course, then we will have this 7, because 4 equals 3 will equal to 7. So we find these points together. Okay? Let's find these points together. Let's write them out separately. I want to write them here so I don't get mixed up, of course. Now the vertex will move from 0 here to 0, 3. This is going to be our vertex. It looks a little bit off today, so very sorry for that, but it should work just as normally, of course. So our vertex that was here originally, it will move up to here. This is going to be our vertex. Now we're going to be sketching that, of course. Just hold up. Let's sketch this. Now it has to start from 3 here and 0. And if this goes from 1 is 4, so there's a mirror point here. 2 is around 7 or so. So 7 here. So it would look something like this. Again, we have a vortex, we have our U-shaped, and we have the vertex being at the bottom point of this parabola, of this U-shaped thing. And we have, it has to cross through the values that we mapped earlier, of course, and there will be mirror points. It's perfectly symmetrical here. Okay, so that's of the equals 3. Now I want to map out minus 2. Y equals x squared minus 2. So I want to move, because I just moved up when it was positive, now it's negative. I need to move down, of course, move down in value. So instead of the point being here or the point being here, I'm actually going to move it all the way down here. Okay, so shifts down by 2. Vertex is 0, negative 2. The vertex will tell you the story. Will tell you the story. It will be the rule, and it will tell you the story. When you find this vertex, it will show you where it's going to be. Okay. Now let's plot this together. We're gonna find if x is 0, 0 minus 2. This will be minus 2. If this is 1 minus 2, this will be minus 1. I'm doing it quickly, by the way. This will be let's see. We just need to shift down by 2 minus 2 points. So it'll be the exact same thing, but we'll shift it by 2. So let's do it together. So 0, 2 here. We'll start it here. If it's 1, then it'll still be minus 1. So it should be here. If it's 2, then it should be 2 here, because 2 squared minus 2, this will be 4. 2, sorry. So we're going to map this out, mirror this. If it's 3, I need to put it, if it's 3, then it's 7, because 3 squared minus 2, it was equals to 7. So I'll put it 7 here, 3, and then I'll map this out symmetrically, minus 3, 7 here. So I just need to draw this, and I draw this, I draw this, I draw this, symmetrically now, U-shaped. Of course, that was a little bit of a blunt. I did not mean to do that. Handwriting is not the best, of course. But we have to make this U-shape. That was not the best one ever, but as you can see, we just map them out according to the height when there's a vertical shift, and vertical shift usually has a form of not squared here, sorry, no square. Y equals x squared equals k, or this can be minus k. It doesn't really matter here. Okay. So that's our first one. Now, second one, there will be a horizontal shift. What's the horizontal shift? So what we need to do is we need to show you an example of a horizontal shift. So instead of a vertical shift like this, A horizontal shift, it means that we'll be adding or subtracting within this x here, x squared here. So what we have is something like this. So we will be something like h. This is b, sorry, not h. Feeling a little bit clumsy today. But this is the form of the vertical one. So this is horizontal shift. Now I'm going to show you an example. Instead of h, I'm going to show you a very visual one. It's going to be 2 instead. It's going to be 2. Now the horizontal shift. Y equals x minus 2 all squared. The vertex will moves from 0 to 2, 0. So instead of it being in the center right here, this will shift to the right. So go to the right here. Even though you go like, oh wait, hold on a second, this is minus 2, this is like negative. Negative means left. Why is it going to the right? So this is a very interesting question, of course, but this is due to the fact that there's a square here where you actually put 0 here on the x, or sorry, when you put 2, when you put when you want to find this thing here, if you want to, sorry, so let me try that again. If you want to know where is the value that makes this y equals to 0, then it means that this part right here, this right side here, it was all needs to be equal to 0 as well. Now we also, so this will be equals to 0, so this would mean that this has to be 0 and x would equals to 2 instead of going to the left. So it's actually going to the right because this is positive. Positive usually means to the right side of the axis. So let's do that right now. So it's because it needs to shift 2 units to the right, so we found our vertex right here, right there, 0 to 2, 2, 0. Now, again, it shifts to the right. This is a classic trap. Again, minus 2 inside shifts the graph to the right, not to the left. It feels very backward. It feels, yeah. But the vertex is whatever value of x makes the bracket equals 0. So x minus 2 equals 0 when x equals 2 again. So I just re-explained that. So let's sketch. So that was how we do this, and because it's shifting to the right just a little bit, we just need to draw the same exact thing. Really, just need to draw the same exact thing. We found the vertex, now we just need to draw this. And so if we put this to 1, this will give us 1. If we give this 2, this will give us 2 as also. If we give this 3, actually, hold on a second. 1 minus 1. 1, 1. If it's minus 1, then this will give us 9, actually, because minus 3 squared will give us 9. But let's just map that out for now. So it will start here, and the graphing itself, it will be something like this. So if it's 1, of course. If it's 3, then it's a 1. So we have to start here. Now, because this is the axis itself, it has to be symmetric. I'm drawing like a vertical line down through the vertex itself. So this will help to promote the symmetry. And because parabolas are usually perfectly symmetric. 4, if it's 4 here, then 4 minus 2 squared is usually 2 squared, and this will be 4. So if we actually put this in 4, then it should map out to this value. And of course, we can't put into a 4 here because we need to put it very symmetrically to here. Symmetrically through this one instead. So through this axis, through the number 2. So let me draw that again to try to make it perfectly symmetrical. I actually give up. I'm gonna do this instead. Yeah, that's way better. So if I put this to, I don't know, say, I have to map this out, of course, and if it's 0, the x is 0, of course, then minus 2 here squared is also equals to 4. So I'm also going to map this point out. It's going to be perfectly symmetrical as well. You can check by substituting them back. I'm actually doing it in my head, but usually through this, it's usually pretty correct. When you again, when you're in doubt, draw it out, of course, right? Let's see, 5. What happens when you put 5 here? Oh shit, sorry. 5, 2, 3. Yeah, I think I'll just draw this out at this point. So it will be looking like this. Why did I avoid that point? Sorry. Yeah, I'm not good at drawing, didn't I, really? But it should look something like this. It should look way more symmetrical and way uglier than this. But I just mapped out x equals minus 2 squared. That should be it. Okay, so now I'm getting into the full form of this. Now this is like going to be like the final boss form of Vertex, and it's going to look extremely difficult and something like that, or whatever. But what we have is a, the coefficient of this part first, plus k. Looks very difficult, right? Looks very difficult. But just let us just slow down first, of course. The full vertex form combines both shifts. Y equals a times x minus h plus squared plus k. Now, of course, what do we have? The vertex always tells the story, and when in doubt, draw it out. This is going to be our two most powerful tools with us, and we're going to have to, of course, check by substituting back. This is like a tradition at this point at this channel, within this channel. Now, the vertex tells the story. The vertex is always going to be at point h and k. It's going to be always at h and k. It does not matter what are these numbers are. This is going to be h and k. So it doesn't matter the a or whatever. It's going to be h, not minus h. So if it's something like plus 9, right? Then the position itself will always be at 3, 9, or 3, 8, or something like that. And so the position should be something like here. It looks a little bit ugly for now, but you get the point. Okay, so we're going to decipher this a. Okay, a, when it's more than less than 0, then it's going to open upward. You can imagine this as like a smiley face. Okay, so when it's more than it's larger than 0, then it's going to be like a smiley face. If it's less than 0, then what we have is a downward. You can think of like it's a sad face. So the value controls the direction. If an a positive, it moves upward like this, and you can think of it as like a happy face. If it's negative, it opens downward like this, and you can think of it like a sad face. If it's greater than 1, then the parabola is narrower. Of course, it's going to be narrower, so instead of like a wide something like this, it's going to be just like this. If it's between 0 and 1, it's going to be wider. So it's going to be wider like this. But, of course, these are just rules. You need something that's pretty visual. So let's try that right now. So let's sketch something pretty difficult. Let's sketch y equals minus 2. Ooh, spicy. It's already negative, so it's like a sad face. Negative 2, x minus 1 squared plus 4. Ooh. But looks difficult. However, you go to the first step. The vertex tells the story. Let's find the vertex. We just find out about the rule that the vertex will be these two numbers here. So 1, 4. So we just need to find 1, 4. 1, 4. This will be our vertex. The red dot one. Here will be our lovely, lovely vertex. So h is 1, k is 4. Now we need to draw a vertical line at x equals 1. So I have to go through here. I'm going to use this tool, draw that line. Why do I want to do this? Because I want to promote symmetry, axis of symmetry. Now I am going to write the A. What is the A? The A is minus 2. I found out about how when I found that A here is equals minus 2, and so because A is less than 0, because minus 2 is less than 0, I will have a sad face. I'll have a sad face. So I'll have it opens downward. And the magnitude is 2, which is greater than 1. So it is narrower than the standard parabola. The standard parabola is y equals x squared, but this is pretty wide, but it will be more narrow. Okay? It will be more narrow. So let's just plot those points right now. Let's do it by same of symmetry. So let me just delete this. We just put right here down here, x equals 0, then it's 4, yeah, whatever, we have that. That's like a vertex point already. Let's put a 0, actually, let's plot 0 first. So 0, x equals 0. So it means that y will be equal, let me just do that out here. We need a little bit more space, of course, to look at what we are dealing with. This will be equal to minus 2. Let me just, minus 2. This will be 0 minus 1 squared plus 4, and this will be minus 2 equals 4, and this will be 2. So we found our first point, x equals 0, this will be 2. So we have plot our point on the left here. Now because we have the symmetry here, we want to make this mirror, so kind of put that on the right. Good. Now we need to find x equals minus 1. X equals minus 1. Minus 1. So it means that y will be minus 2, minus 1 here, squared plus 4. This will give us, let me check, minus 2. This will be minus 2 squared plus 4, multiplication first, plus later, addition and subtraction later, so minus 2, 4 plus 4, this will give us quite a process right here, so minus 8 plus 4, this gives us minus 4. So we found our next point, this will be minus 1, minus 4. So let's look at here in our graph, we need to find minus 1, minus 4, minus 1 on the x-axis, of course, on the x-axis, and a minus 4 right here. So let me just zoom in to be very correct here with our point, minus 1, minus 4. Okay, minus 1, minus 4, and because this is going to be a symmetrical one right here, down here, so we need to map that out perfectly and mirror that. So 2 here, I need 2 here, so I'll map that second point. And so what we have done here is we have enough points now to plot those points. So because this is a downward one, I'm going to draw those. So I'm going to draw from the left side first, and I'm going to draw the right side later. So this is going to be looking like this. Oh, sorry. Long lesson. Oh, man, I can't draw. Hold up. Ooh, okay. Slightly better. But I'm mapping it out. Again, we need to remember A is minus 2. It is smaller than 0. And this is going to be a down one. A sad face, of course. We need to draw this. We missed the point, but again, we're going to go through the point, of course. So this will be our graph. We need to connect them into like a smooth curve or so. The parabola will open downward again. Sad face peaks at 1, 4. Again, I'm going to make this 1, 4, and falls away on both sides because A is a negative 2. Remember negative 2 here? The vertex is a maximum point, not a minimum. Okay? And so if any examples where x is suddenly a is suddenly like +2 or something like that, like +2, then it becomes something like it has this kind of shape instead. Again, a is bigger than 0, smiley face, opens upward. Okay, very messy lesson, I know. Okay. I do want to go through just a little bit, of course. So when you guys notice that when the curve crosses the x-axis, so let's just go through here. When it actually crosses the x-axis, these are the same roots, of course. These are the same roots, of course, to if we solved something like this. So this is going to be a very hard thing. I need you to focus just a little bit more. But if we solve something like -2 x minus 1 equals 4, then we need to find the values that make x that make y equals to 0. And so if you look at how they cross the x-axis here, it means that all of these red points here, these are the points and these are the values that make y equals to 0. These points are usually pretty hard to map out because they are not very elegant or beautiful numbers or so. They're usually going to be, it's pretty hard to estimate. But again, when in doubt, draw it out, and you can usually visually see where's the range of these values. So we've learned the vertex tells the story. We've learned about when in doubt, draw it out. We have repeated this a lot of times by now. And we're going to be, of course, check by substituting back into your own notes, because exams do not really care about when you have the right idea in mind. You need to write them out perfectly and correctly. So today's habit, again, first one, vertex tells the story. When you see a quadratic in vertex form, read off h and k. Read off these values right here. Read off what is going on after x. Plot out the vertex, draw the axis of the symmetry, plot out these points, draw the axis, check the sign of a, whether it's negative or positive for a direction, whether it's upward or downward, and plot 2 extra points. That is going to be the complete recipe. It's a little bit messy, yes, I know, but you do this 5 times and you usually 5-10 times you usually get it. In the next video, we're going to be applying everything we've learned to a real-world modeling problem. We're going to be using that to maximize the area of a rectangular paddock. You won't see it here, of course, but you'll see it in the next video. I'll see you there. Thanks for watching.